atomic scale. The equations had been around since the 1920s, but figuring out how to interpret those equations, to parse the symbols in words and scrutinize just what they implied about the mysterious workings of the micro-world, that interpretive task had long since fallen out of favor. During the middle decades of the 20th century, most physicists recoiled from such philosophical labor. They treated the interpretation of quantum theory as a fringe topic, a fine leisure time diversion for retired researchers in their dotage, perhaps, but not the sort of activity on which rising stars should spend their time. 30 years ago, readers who were interested in the unsettled debates over the interpretation of quantum theory had to hunt in some out-of-the-way places. In 1979, some of the most extensive coverage appeared in an unpublished memorandum from the Central Intelligence Agency and a feature article in Oui magazine. The latter, no publication of the French embassy, was Playboy's answer to Penthouse. Both items focused on work by physicists at the center of this story. The porn magazine's discussion was by far the better researched and more accurate of the two. Lost from view in today's hoopla is a story equal parts inspiring and bizarre of scientific striving in the face of long odds. The intellectual bedrock of quantum information science, the ideas that undergird today's quantum encrypted bank transfers and electronic voting, took form in a setting that couldn't have been more different from the ivory tower of academe or the citadels of business and politics. In fact, the breakthroughs in Vienna and Geneva ultimately owe their origins to the hazy, bong-filled excesses of the 1970s New Age movement. Many of the ideas that now occupy the core of quantum information science once found their home amid an anything-goes counterculture frenzy, a mishmash of spoon-bending psychics, Eastern mysticism, LSD trips, CIA spooks chasing mind-reading dreams, and comparable Age of Aquarius enthusiasms. For the better part of a decade, the concepts that would blossom into developments like quantum encryption were bandied about in late-night bull sessions and hawked by proponents of a burgeoning self-help movement. More snake oil than stock option. The woolly pursuits of the 1970s harkened back to an earlier way of doing physics and of being a physicist. The roots of quantum information science stretch all the way back to the golden age of theoretical physics of the 1920s and 1930s, when giants like Albert Einstein, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger cobbled quantum mechanics together. From their earliest wranglings, they found themselves tangled up with all sorts of strange, counterintuitive notions. Many have become well-known catchphrases like wave-particle duality, Heisenberg's uncertainty principle, and Schrödinger's cat. Each signaled that atomic-sized objects could behave fantastically different from what our usual experience would suggest. To Einstein, Bohr, and the rest, it seemed axiomatic that progress could only be made by tackling these philosophical challenges head-on. Manipulating equations for their own sake would never be enough. That style of doing physics did not last long. The clouds of fascism gathered quickly across Europe, scattering a once tight community. The ensuing war engulfed physicists around the world. Torn from their pre-war routines and thrust into projects of immediate, worldly significance, radar, the atomic bomb, and dozens of lesser-known gadgets, physicists' day-to-day activities in 1945 bore little resemblance to those of 1925. Over the next quarter-century, Cold War imperatives shaped not just who received grants to pursue this or that problem. They left an indelible mark on the world of ideas, on what counted as real physics. Physicists in the United States adopted an aggressively pragmatic attitude. The equations of quantum mechanics had long since lost their novelty, even if their ultimate meanings still remained obscure. The pressing challenge became to put those equations to work. How much radiation would be emitted from a particular nuclear reaction? How would electric current flow through a